In this presentation I will discuss explosion relief in Type B gas appliances, and it is for a general use only and should not be used for design purposes. I will use the AS1375 standards as a reference. The topics that will be covered are what is explosion relief, and also what is the maximum allowable pressure that's allowed within an appliance or combustion chamber if an explosion does happen. Is the appliance considered a cubic or near cubic, or is the combustion chamber or appliance longer or an elongated appliance and therefore must be divided into smaller sections for relief vent purposes. Next thing we will have a look at determination of relief vent areas for the various appliances, and also we will look at a worked example for explosion relief. Terms that will be used during this presentation is an explosion. And what is an explosion? It's the occurrence of an uncontrolled combustion with which a flame front propagates from the source of ignition. Next one will be maximum allowable pressure. It is assumed that for the purposes of AS1375 that a pressure of 7 kPa is generally unlikely to endanger personnel, though it may damage the appliances. Also the relief area, the net effective area of relief vent openings in square meters. If the Type B gas appliance or combustion chamber is cubic or near cubic, the following formula shall be used. R equals 8 times AS divided by P, where A equals the net effective area of the relief vent opening in square meters, A equals the least cross-sectional area of the appliance in square meters, S equals the flame propagation rate in meters per second, and P equals the design pressure or the maximum allowable pressure in kPa. To determine whether the combustion chamber is cubic, the following formulas shall be used. L is equal to or less than 2.25 times D, P is equal to or less than 35 kPa, or V is equal to or less than 100 cubic meters. The first worked example we are going to look at is a combustion chamber size of 3.5 meters by 5.4 meters long by 3 meters high, and the solvent being evaporated within the combustion chamber has a flame speed of 0.5 meters per second. First we must find out is the appliance cubic or near cubic. Therefore, firstly we determine D, and D equals 4 times A divided by the perimeter. Therefore D equals 42 divided by 13, therefore D equals 3.23 meters. If we look at L is equal to or less than 2.25 times D, therefore 5.4 is less than or equal to 7.267. Therefore we can consider this combustion chamber to be cubic or near cubic. Because this Type B appliance is cubic or near cubic, we will use the formula R equals 8 times AS divided by P. A equals 10.5, S equals 0.5, and P equals 7 kPa, being the explosion pressure for over 3 cubic meters in volume as per E 4.2. Therefore R equals 6 square meters of vent opening. For the second worked example, we are going to have a look at what the explosion relief is required for a tin plate drying oven, and the oven outlet has an opened ends of the oven. The size is 1.8 meters wide, 2.5 meters high and 40 meters long. The solvent being evaporated has a flame speed of 0.5 meters per second. Firstly we must determine is it cubic or near cubic, where we must find D. Therefore D equals 4 times A divided by P, and therefore D equals 2.093 meters. If we look at L is equal to or less than 2.25 times D, if we calculate that out, that is 40 should be equal to or less than 4.7. In reality it is larger, and therefore this appliance shall not be considered cubic or near cubic. Because this example is not considered cubic or near cubic, we must divide it into sections. Therefore D equals 2.25 times 2.09, which equals 4.7 metres per section. The complete length of the oven is 40 metres. We divide it by 4.7. Therefore there's 8.5 sections of the oven. We must round that up to 9 sections or lengths along the oven, which is 4.44 metres in length. Because the oven has open ends on it, we can use that as explosion relief, and therefore we will consider that the oven has 7 sections. We shall use the formula R equals 8 times AS divided by P, and therefore R equals 2.57 square metres per section of each of the 7 sections. In this presentation we have had a look at explosion relief, and explosion relief is the area that is required to relieve pressure from a combustion chamber if an explosion does happen. We have had a look at how much explosion relief is required, and we have had a look at where do we find the formula for relief of explosions, which is in AS 1375. We've had a look at determining whether a combustion chamber is cubic or near cubic, or whether it needs to be divided into sections, and we have done 2 worked examples, one which is cubic or near cubic and one that is elongated. If you need any further information, please ring Greg Hager on 03 9251 3024.